Hey guys, I'm really sorry about that. Now let me just see where I'm meant to be. I'm meant to be over in YouTube. Right, bear with me while I just figure out what the heck I'm doing. I think I'm getting there. Right, let's go back to this main window. Boys, can you just tell me if you're here again so I can check who's got back in? Sorry, I just had to restart because something really weird happened. And I'm just trying to fix it up now. So I think we're good. What we're going to do, I know we're running a tiny bit late, I'm going to run this in two groups and I'm going to go really slowly through the two topics that we're doing first. So I think if you're in the back table groups, probably the right time to join in is going to be around 5 to 1. Okay? No. Right, so who's all in there? Let me see. See if I can see you guys. I can't see you. Why can't I see what's going on? Let me just have a look. Am I live streaming or not? Right. Oh, you're all there. Okay, guys. Right. Just hold your horses. Oh, no, I can't do... I know what I'm doing. I'm doing the same thing I did before. I'm doing the chat in the wrong laptop. Okay. Right. So, what do I need to go to? I need Cam to come back. Cam, are you out there? Yeah, Jay, I know my stream crashed before. Oh, I'm live now. Okay, guys. I think we're back up and running. I can see you and I can't see the chat though. This is really weird, guys. Hang on. Live now. Live now? What's happening? This is really embarrassing. Right. Okay. Yep, Fergus, go do some Education Perfect. Theo, go do some Education Perfect. Toby, go do some Education Perfect. JB, stay here. Roy, go and do some Theta textbook. I think this is going. Let's see. What do we got? Right, yes, we are back in. Now, the lag, but I can't do anything about it. Right, so let's have a wee look at what we're going to do. So today we're going to look at how to add and subtract like terms and then how to multiply expressions. So let's see who is still out there. Guys, can you just really quickly type in kia ora miss or something like that so that I can see what's happening. Now, Henry, just want to remind you that this is a completely public forum, so all of your comments can be read by anyone who's in here. So if you wouldn't say it in class once we were working, don't say it now. Okie doke. Right, let's go. So what I'd like you to have in front of you, boys, is your lesson sheet that I gave out in class yesterday. Okay? So the lesson sheet is this one here that I'm now going to attempt clumsily to turn around. Let's see. Can we rotate it? Yep, we can rotate it. Let's see if we can do that. No, we'll do that again. So it's upside down. I know you're all sitting there at home laughing at me. I can hear you laughing. Nikki, nice to see your brother here. That's good. Okay, here we go. Right, so this is the worksheet that you took home yesterday, and this focuses on two different things. It's got like terms in it, and then it's got the thing that we haven't done yet, which is multiplication. So this section down here is going to be the brand new stuff for today, right? So how we do multiplication is the new thing. And this section up here is what we've been working on with our like terms. So for about the next 15 minutes, I'm going to go over like terms using these examples, and then you can go and do the Education Perfect. Now, Kafor, you've been away, so you can have a look at what I'm doing, just do what I'm doing on the screen, and then you can go and do the Education Perfect work. Okay? Just writing a wee comment to Kafoa. So, let's see what the big ideas are again. Right, so I'm just going to tell a few of you to come back at about 5 to 1. Leo and Quinn, I'm going to go pretty slowly now, so you're very welcome to stay, but you might be better to go and do your Education Perfect now, and then come back for the very fast version at 12:55. Kia ora, Jackson. right? I'm just seeing who else is on here. Let's have a look. Yep, Quinn, S, come back. Leo, if you've already done your EP, you can disappear until 5 to 1 when I'm going to do some harder stuff. And you can go and eat your toast, make coffee, have some lunch. Roy, just a message for you. What I want you to do in the textbook is find the section on completing the square and the discriminant. Okay, so go to the algebra section. All right, thanks for all the instructions. Okay. Yep, thanks for all your comments, guys. It's just lovely. Yeah, JB, you might have the wrong sheet. It doesn't really matter. We're just going to go with this and do the best that we can. Okay? So, like terms, how do they work? Right, so this should be starting to feel pretty easy by now. And we want this to be at a level where you can see these questions and know exactly what to do. So, I'm just going to pick out the first few on the sheet. And we're going to have a look at these. Right, what I'd like you to do is either writing on your sheet or kafoa for you just writing them down in your book. I want you to write out the question and the answer. So this is like the starter that we usually do in class. Yep, so I'd like you to have your sheet and have the book. Okay. Right, let's go. So, can you type in now, boys, what your answers are to those 3 questions? Just type them into the chat and let's see how you're getting on. Right, so I know there's a wee lag, so this is going to go quite slowly on purpose. All right, so go get your sheet if you need to, and then just start doing these questions. Okay, so let's have a wee look. What do we got? Here we go. Right, we're back in here. Okay, who's in the background audio? JB, just worry about the work. The background audio is my son playing his guitar. Okay, so this is looking really good. Yep, the first one. Well done, guys. The first one is 9p. Why can I put these together? Well, it's because the letter is exactly the same, right? So these are called like terms. Remember, this is a term and this is a term. When the letter's the same, we can combine them, so we get 9p. This one is 9t plus t, and that's equal to 10t. Now, I like this example because it lets me go over one more convention in algebra, is that we don't write it like this, right? We never write 1t. It just looks silly. But we could, it's not really wrong, but we never do it. It's a very strong convention. So we've got 9t plus one more is 10t. Here we've got negative 3e plus 8e. Let's see. Quinn, Bailey, I'd like you to come back at 12:55. Yep, looking good. Who's got that last one there done? Yep, Jackson, the first one not quite right. Jules back. 12:55. Okay. Right, you guys go and have a rest. Right, let's get going. Now, who's done that last one? Let's have a wee look. Okay, so this one here, I've got a negative 3e plus an 8e. Okay, so I'm starting back here at negative 3e. Here's 0. And I'm going forwards 8e, right? So I end up here at 5e. So I'm going... Just a sec, I just need to get my daughter to turn her phone down. I'll be back in a sec, guys. Teresa? Yeah? I can hear that coming down the live stream. Can you just do it somewhere else? Or turn your volume off, please? Thank you. Okay, it's going to interfere. Alright, sorry about that. We've got the whole family working at home here today. It's a little bit crazy. Right, well done, guys. Yep, it's 5e. So we start at negative 3e. Oh, where'd that go? And then we're going forwards 8. So we forwards 3 gets us to 0, and then 5 more. So the answer is 5e. Good job. Okay, let's just do a few more. I'll just add another page. Let's step them up a little bit. So this is question number 4, number 5, and number 6. And I'm going to start just making them up because you guys are getting it pretty well. So you're going to be doing the sheet very quickly on your own. So let's do this one. Negative 3a minus 5a. 4ab plus 7ab. Negative 2k plus 10k. Right, guys? Same thing again. Do those 3 and then chuck in your answers. Okay, Drew Tansley, 5e, very good, right? Okay, so I'm starting to see some answers coming up. Now you've got to really watch your integers here, guys. This is actually more about integers than it is about algebra. Think about what we've got here. We've got negative 3a. Here's my 0 on the number line. So here's negative 3a. I'm starting here. And then I'm taking away 5a. So I'm going in this direction, right? Remember the crazy lesson when I pretended to be a train, right? So I end up at negative 8a. So that one's negative 8a. Let's see. Yep, Roy, go away and come back at 12:55. Okay, this one here. These are like terms, so I can put them together. I've got 4 of them and then 7 more of them. It doesn't matter that it's AB, it's still a like term. So that's going to be 11AB. Okay, this next one, you guys are doing well. What have we got? Negative 2k plus 10k. So we're thinking about our number line. Here's 0. I'm starting at negative 2 and I'm going forwards 10 to plus 8. So that one's 8k. Just a moment, guys. Yep, hang on. Alright, so that's those ones done. Okie doke. So hopefully those ones are starting to make sense, and that's the first thing that Education Perfect's going to test. Now yesterday we started looking at some harder ones like this. If I've got x squared, that means x times x, right? And that's not the same as just an x. So if I've got 3x squared plus 5x squared minus 2x minus 6x, what can we combine in here and what can we not combine in here? Well, I've got this one is an x squared one, and this one is an x squared one here. So they go together. I'm sorry, I'm speaking up because there's quite a lot of background noise at my place, so hopefully you can still hear me. Okay, just one sec, guys. Yep, that's fine. I just need to talk to my daughter quickly because she's making her lunch. It's totally fine. Okay, it's totally fine. Okay, you just do what you got to do. Right, so the x squareds are like terms, and then here, these are both x terms, so they go together. But they don't all go together, right? So we combine them in bits. So we get 8x squared, and then we get minus 8x. Okay? Right, so let's do a few like that. You try these now. We've got 3, t squared minus 5t minus 8t. There's your first one. Here's your second one. 6x plus 10xy plus 3xy. Here's your third one. 4a squared minus 7a squared plus 8ab plus 9ab. So off you go. Have a go at those. And I'm going to just pause things here. I'm just going to do the roll and see who's signed in. So let's have a wee look. So if you are here but you haven't got a Google account, can you send me a quick email so that I know that you've made it? That would be really good. Okay, right, let's see how we're going. Okay, guys have just come back in. I'm just trying to catch up with what people have done. So Ned Flack, who's Hugo W? Right, guys, I just need to talk to a couple of people in here. So Ned Flack, you are stopping us being able to work effectively on this platform right now. Please think about what you're doing and either take part properly or stop spamming us. Okay? Because my class is working and they are going to type in the answers to those 3 questions. So Torben, you also don't need to say hi 10 times. Okay? People in the fast group, I'm happy to see you back. Okay, thanks Noah. Right, I'm looking for some good answers. So, Noah, you're nearly right with that, except that we've got 6x, and here we've got the xy's. So these go together. This one is different. Okay? Okay, so Jay, the same mistake coming up. Be really careful when you're looking for like terms. This one is 6x plus 13. Can you, sorry, just one sec. Do you mind not doing that right now? Thanks. 6x plus 13xy. Okay? Yep. So it's 6x plus 13xy. Right. Now let's try that last one. Okay, boys, I'm waiting for you to type in your answers to that third one. Okay, so this next one, that should be long enough. Let's look at what our like terms are in here. Well, this is an a squared, and this is a minus another a squared. And these are ab, and this is an ab. Okay, so they go together, and they don't go together. Right, so these are one set of like terms, and this is another set of like terms. So let's just see what we've got going on here. Well, the first ones, it's my rainbow sparkly pen, give me negative 3a squared. And then the next one gives me 17ab. Okay? Right? So, JB, you've got the negative 3a squared, but this is, both of them are pluses, right? So it's plus 8, plus 9. So it hasn't got any negative numbers in it. Okay? So Henry, that's right. All right, so the next thing I want to teach you, that's all we're going to do on like terms. Okay, what we're going to do now is that you can choose, I'm going to go on to the harder booklet work now, guys. So, right, I'm going to move on now to the harder booklet that we've been working on. So people in the back table groups, you are really welcome to stay. Some of you are more than ready for these questions, but I think a lot of you, if you're in the front table groups, you need to do some work on your integer skills. So this page is for the back table groups. Front table groups, you can either do EP or you can stay, right? But you have to do the education perfect work, okay? Okay, Oscar, if you could just let Henry focus on what's going on the lesson instead of a whole lot of discussion in the chat. Right, back table groups, we're going to go through quite a lot now. Right, so I'm hoping that you've got your harder booklet with you. Yep, JB, you're welcome to stay. Yep, pardon? Yep, that's fine. Right, so what we're going to do is I've managed to copy over some of this booklet so that we can do it together now. Right, so in general, guys, what I would say about why this chat's not working as well as my Year 10 one is that you're filling up the chat with questions about what you should be doing, right? And that's fair enough, but basically, some of you will have already finished this front page. You can just make a choice without asking me of what you do. So you can either just sit there and have the sound on, and then when I get to a harder bit, you can come back, or you can do EP, right? But what I'm going to do now is look at this booklet that I made you from a fabulous English website, and that's this one here, right? So this is called mathsforeveryone.com, and the maths teacher who writes these is a teacher called David, and he said that I could use his worksheets in my live stream. So big shout out to him. We're going to look at some of these questions now. And the questions in these sheets usually start off pretty easy and get a little bit harder. So I'm going to quickly go through row A1 now, and I'm going to pick my speed up significantly on what I was just doing. Okay, so the key thing that we want to make you guys do is really good working with these. So I'm going to write each of them out. So 3a squared plus 5a squared is a pretty straightforward one. I've got 8a squared, right? The a squareds are like terms. The next one, 5a squared plus 2a squared plus a squared is also going to be 8a squared because this is 1a squared. Okay, a3. This one here, 2a squared minus a squared, or 2 minus 1 is 1. So these are like terms, so this is just a squared. Right, now this next one is where we start to have to check. We've got 5a squared minus 3a squared. They are like terms. This is a plus a and this is a plus a, so those are like terms. So that gives me 2a squared plus 2a. So just mark as we're going. Right, so next row, B1. I'm going to get some check-in from you when we've done a few more, but I think most of you guys who are watching now would have found this like terms sheet pretty good. We're going to get on to some multiplication shortly, if we can go fast enough. Okay, so in here, B1, we've got 2bc plus b plus c plus bc. These are the only like terms, so we've got 3bc plus b plus c, right, B2. Here, what have I got? Well, I've got 5bc, take away 3bc. That gives me 2bc plus 4b minus 2b, so plus 2b. Right, next one. Like terms here, I've got 6bc minus bc. So we have 5bc plus c plus b. B4, what have we got? Well, we've got 3bc plus cb. Now, notice that a bc is equal to b times c, and a cb means a c times a b. So they are still like terms because the order doesn't matter when I'm multiplying. So I've got 4bc plus 3c. Okay, I'm going to pause it there, guys, and can you just tell me if you're still here, and tell me if you're getting it all right. Right, how are we looking? Let's see if we've caught up. Let's see. Yep, still here. Yes, good. Kieran, you're going to stay. Great. Roy, you're here. Good. Still here and done. Doing some EP. That's lovely. It's really hard to get the pacing dead right, guys, so we're just doing my best. Okay, quickly onto these ones. So I'm going to go really fast now because I want to get us onto index expressions. So in here, I've got to notice here I've got a sneaky thing. I've got d squareds here, but I've got a d cubed here. So I can't mix them all up. So it's going to be 3d plus 6d squared plus d cubed. Right, in this next one, I've got d squareds, I've got a d, and I've got an e squared. So let's do the d first. The order doesn't matter, right, but it's nice to kind of have a pattern. So I'm starting with the lowest power here. So I've got d, and then I've got 3d squared here, plus 2e squared. Okay. Right. Just some feedback. Are you getting them all right so far, guys? Okay, just a quick correction. So right, okay, so let's keep on going. I need you guys to post and say if you're getting it right. Right, so let's just hear from a couple more of you. Toby, we good? Fergus, we good? Okay, thanks for your patience, guys. Right, I'm going to keep on going. I'll try not to get any more wrong, but I probably will. So this next one, we've got 6d plus 2d squared. In the next one, we've got d plus d squared plus 2e squared. Right, is there anyone in here from the back table groups who's having trouble with these? If there is, can you just tell me? Because I think what I'm going to do is skip right on to indices and powers. Looking good, guys. This would also be a good time for a little bit of feedback about how you're finding the live chat. You're being very patient with me, that's for sure. Just a sec. Right, working good? Ooh, yep, I'm getting it right. It's fine. That's good, guys. I'm just going to mute you for 1 second, okay? Alright boys, I'm back. So, let's go a little bit faster now. Thanks for your patience. It is quite hard doing differentiated teaching over the internet. So, guys, the more you can keep the chat to the maths and not the jokes and not the highs and not the we'll see you on the turf, the faster we're going to go. Alright, so now we're getting into multiplication. And I'm going to teach you guys kind of 2 bits of it mixed in together. So when you get to the Education Perfect, it might go a little bit more slowly than what I'm doing. I still want you to do it all, but just skip through the wordy explanation stuff. Okay, so if we think about multiplying numbers, this is quite different from the idea of like terms, right? So if we've got 2 3s, that's the same as 3 2s. Now, if I've got A times B, the first thing is that in algebra, we never write that times sign, right? So we write that as AB, but that's exactly the same as B times A. So what you have to quickly get used to doing is seeing AB as exactly the same thing as BA. Now the next thing to think about is what we know in number when we've got powers is this. If I've got 2 times 2 times 2 times 2, we write that as 2 to the power of 4. So not surprisingly, when I'm doing algebra and I'm starting out, if I see this, A times A times A times A, that equals A to the power of 4. So, what if we had this? 2 to the power of 4 times 2 to the power of 3. So I want you to type into your comments now what the answer to that is as a power. So don't write me out 128, which is what the answer is. Think about how can I write that out as 2 to the power of something. Now I know there's a lag, so I'm just going to wait here for you guys to do that. Right, this is great, guys. Great. Okay, so we're seeing it. It's 2 to the power of 7. Well done. This is starting to work. We've got no more silly comments, and we've got some good maths going on. Right, so now let's have a think about algebra. If I've got a to the power of 3 times a to the power of 5, I can write that out once, and I don't want to do it more than once in my life because it's very painful. I can write it out like this. A cubed is a times a times a, times a times a times a times a. 1, 2, 3. I've got one more to go. Right, so that's a cubed here times a to the power of 5. And that's a to the power of 8. So what do you notice? Well, what you notice is that we could have got there much faster by adding these. So in general, if we have x to the power of 3 times x to the power of 7, that's going to be x to the power of 10. Well, that's not in general, that's another example. X to the power of 6 times x to the power of 2 will be x to the power of 8. Now what if I had 2x cubed times 5x squared? What does that mean? Now this is where people start to go a bit wrong. Let's just write that out. I'm going to do one for you first, and then I'm going to do a couple for you to try. So here, this means 2 times x cubed times 5 times x squared. But we know that the order of multiplication doesn't matter. So this is the same as writing 2 times 5 times x cubed times x squared, which equals 10 times x to the power of 5, which gives me 10x to the power of 5. I'm going to leave that example on my screen, and now I'm going to pick off some of the ones on the harder sheet. So I want you, actually there's a really good row on the harder sheet, row C on the multiplying terms sheet. So get that booklet, guys, and I want you now to check that you understand this example, and then do the 4 questions in row C. So the first one is 2a squared times a, and then 5b times b squared, 4c squared times 3c cubed, and what's c for? 7d squared times 2d squared times d. Okay, so I'm going to give you a couple of minutes to do that. And then I want you to just type a few of your answers in. I know it's pretty painful typing the answers into the chat, but it's the big benefit of doing the live stream. It means I can see if you're roughly getting it. Okay, seeing some lovely stuff, guys. Really, really good. Damon, pretty cool having you in here, but you are in year 13. Right, let's go. Let's have a think. Now, there's a few things that are going wrong in here. Theo, you are dead right on this one here. So this one here is 5 times b squared. Now, b times b squared is b times b times b. You can think of this b as having an invisible 1. Right, so this is indeed 5b cubed. So well done to Theo M for getting that one. Let's look at that first one. What's this one? Let's see what you've said in the chat. Close but not quite, guys. So they suddenly start to get a little bit harder. It's not 2a to the power of the 2. It's 2 times a times a times a. Again, this a has got an invisible power of 1. Now, I could have told you that, but I wanted you to work that out for yourselves on purpose. Okay, so if there's any other maths teachers out there going, man, she didn't teach that very well, that was deliberate, right? What I want you to see is that whenever I see an A or a B in algebra, I can always think of it as A to the power of 1, B to the power of 1. And then the rule that we started to work out up here was that when we've got the same base, we can add up the powers. So in here, this one will be 2a cubed. Right, so this next one down here, what have we got for this? I've seen some 12s. Yep, it's definitely got a 12, right? Because it's 4 times 3 gives me 12. And then it's c squared times c cubed, which is c to the power of 5. Good, okay. Oscar, I can see you've got that one. And then the last one, let's see if you've done that last one. Theo, you've got it. You're good to go. Right, so you should be able to do that whole booklet page, actually. There's one thing I've got left to tell you. And then I'm going to go and see my year 13s. So this one, there's a d to the power of 1, invisible number 1. Let's see, number 4, C4. I'm just reading your comments. Right, Fergus, not sure you've got it yet. That's okay. Well, I'm going to do this one a little bit more slowly. So this is going to be 7 times d squared times 2 times d squared times d to the power of invisible 1. Remember, we can reorder multiplication. Okay, so it's going to be 7 times 2 times d squared times d squared times d equals 14 d to the power of 5. Right, so quick comments. Can you tell me, please, guys, are you a green traffic light or an orange traffic light or a bright red traffic light? Okay, so let's do what we do in class. If you've totally got it, are you green? Just type this in. Green, or are you orange? And most of you will be green or orange. Green, orange, or red. Okay, let's go. What are we thinking? Can you come see? What's the matter?
Anyone listening? Anyone listening?
Everyone's listening, yeah. My class is here. Do you want to say hello? Okay. Yep, Oscar, you're green. Toby, you're orange. So orange, boys, I think I might do a couple more. Right, if you are green, right, guys, looking good. So no one's coming up as bright red, that's good. Let's see how we're getting on. Good stuff. Right, guys, I'm just going to do a few more for people who are orange. So orange examples coming up now. Let's do some more. Let's just do these three. Okay, so the key mistake is this. And Oscar did this, and he's probably the 100th person I've seen in the last 8 years do this. Our brains go like this. We've got a to the power of 4 times a squared. Now we know that we want to add those powers, so it's going to be a to the power of 6. But then our brains also go, oh, this is a 1. And our brains are still in adding mode. But that's not right, because what we're doing here is we have to multiply this. Right, so 3a to the power of 4 times a squared is going to be 3a to the power of 6. It's not going to be 4a to the power of 6. In this one here, we're looking at these coefficients and we're multiplying them, right? So it's going to be 4a to the power of 9. That's right, Quinn and Jules, it looks like you've got it really well. Next one. This last one is going to be 35x to the power of 9. Okay, guys. You have worked really well after you got used to the chat format, so I'm hoping that'll go away. So thanks so much for watching. I'm just going to get a quick look at who the participants were and see who's still in there. So really good. Thanks for coming on, and enjoy the rest of your weekend, and I'll be keen to hear how the rest of the learning at home's gone when I talk to you later on next week. So I'm going to hang up now.